Hi, just a little update on my video modulator replacement circuit. And now I have this stripefix project that I'm doing. I do not have all the parts I need, so yeah, I have my disk drive here open so I can borrow chips. So what I need is an inverter. So I have, actually there are two here, but this one here is the one, the 7414 is the one that is the best one, because the other one pulls so slowly up but fast down, but this one pulls, yeah. Yeah, I will move that chip over now. Okay, so the chip's in the circuit now, and I did the experiment with this last night. And you can see on the top here there's the circuit that I showed in my previous video, but here's the new one. The orange line here, that's the AC signal, and I believe that that's the signal I can use to remove or counteract the interference by sending interference back to this picture signal, and then if you send it back in the opposite direction, then in theory it will counteract the noise, so or at least some of it. So, and the blue pot here is for adjusting how much I want to send back. So, and also I don't have all the components I need, so what I've done here is to yeah, so I want to couple the noise back to where the noise comes from, and to do that I send the signal through a capacitor. So I think it's 2 picofarad in the one I'm holding, and the one to the right it's actually I don't know. So, but it should be 47. I'm getting new components soon, but for now I'm using 2 picofarads. So it's not a lot, but I can, and it probably won't be the correct. So the AC signal comes in here, and it's inverted, and then it comes out again inverted. So it's basically the same. It's of course it's a bit delayed, but not much. And then it goes into this potentiometer, so I can sort of adjust the volume, how large the signal will be. And then it comes through these capacitors that sort of filters away all the low frequencies, so you just get the spikes. And basically that's how the noise happens in the first place. It is coupled with capacitance usually, and that's called capaciting coupling, and that's actually what I'm doing here. I'm trying to do the same thing but in the opposite direction, and to get the opposite direction we use the inverter. So this is not an idea that I got from myself, it's something I read on the forum. And as you can see here, this output here goes back to the Luma signal that comes from here. So it sort of is mixed in there now. Okay, I'll connect myself to the inverter where the AC signal comes, and we can look what it looks like on the other side. Okay, so here are the signals. So let's speed up the scope a bit. Try make it oscillate faster. Let's try 1 microsecond per division. And there you can see on the top that that's the AEC signal, and the bottom is the inverted signal of that. So let's take it and let's move it on top of the other, and now you can easily see how the signals are inverted of each other. So let's try and speed it up a little bit more in the scope. Yep. Let's freeze it. Okay, so here, if you remember my last video when I thought about NMOS technology, you can see how fast it turns on when it pulls down, but when it releases, it's not that fast when it goes up again. Anyway, but after inverter, it pulls both ways very fast, as you can see. Yeah, so what we want now is to pick up the transition here and kind of bump that into the Luma signal. So let's try and measure on the Luma signal. Okay, just bear with me here. On the top you have the Luma signal that we looked on yesterday. So this is one frame. No, it's not one frame. It's from left to right on the screen. So you have your right border and your left border. And this is the output of the inverter. And we should see a bump here for every transition. So let's try and go a bit further in here. Okay, this isn't working. I was trying to get this in real time. Okay, let's try this. Now I'm going to turn the knot. Can you see that? There. So let's try and zoom in on it. There, I can freeze the picture. There you can see. And let me show you the screen now, how terrible it looks. This is my signal. It's actually making it worse, but at some point it's actually counteracting. So let's try and yeah, let's try and do this and holding the thing, the camera at the same time. So there. Let's continue. Okay. Okay. So. Okay, now I have pulled out AC, so you can see there's the white lines. Now if I put it back in again, there, oops, you can see that it sort of, yeah, it's counteracted. So let's try that again. Now it's out. Now it's in again. Out. And in. So we can try and fine adjust this a little bit more. So this is the wrong way, as you can see. Now, and you see here the white lines reappears. Then I have to move the signal up again. I mean the counteract. I have to counteract more. So there. So yeah, oops. There, I think I can't get it any better. So yeah, I hope you liked it. So I will try and make, and there are more things you can do to improve this. So what I'm thinking of doing is, let me just switch it off, is making a PCB board that goes between this chip and the motherboard, so I can have all this blue potentiometers here, and then yeah, so, and then you can get access to the signals you need right at the pin, and that will also increase the quality of the signal. So yeah, thank you very much.